Okay, next I want to talk about this keyword extends. And this ties in with the object-oriented concept of inheritance. And let's create a program that will demonstrate this. So let's create a new Java file. We're going to call it public class car. And a way to think of inheritance is to think of human beings. If we were a computer program, there might be a superclass that we can inherit called human beings that will allow us to have some of those attributes in the sense that all human beings might have similar characteristics. So to pick a simpler metaphor, I'm just going to use cars. So we have this one, public class car. I'm going to go ahead and save it. And it's not going to have a main method because we're not going to run this one directly. But it's going to have its own methods. Public static void accelerate. That's something that all cars generally do. Now, let's not overthink it and say, well, what about a car that doesn't work? In this case, we will assume the car works. And then, just to test it, we can put in system out print statements. Let's go. So when the car is accelerating, we'll know that's the case. So that's a method. And the word static in this context means that it's not affiliated with any object, in the sense we're not doing anything like car, my car is equal to new car, and then doing car dot accelerate. That's when you would not use static, because you're associating a method with an object. So since we don't have an object, or we're not going to be making an object out of this class, we're going to be inheriting it, we have to make these static methods. You'll know this is the case when you get error message that says you can't access this from a non-static concept or context. So let's create a few more methods that hopefully most cars have. So we'll assume most cars can brake. And in that scenario, we'll slow down. And we can also turn. So our car can turn. And for this, I'm just going to say I'm turning. Let's compile it. All right, so this is a class we can use. We can't instantiate it or create an object from it, but we can use it for inheritance reasons. So the reason we might code this way is there are hundreds of cars out there, and rather than code an acceleration method, a brake method, a turn signal, all sorts of things that they all might share in common, we can have it here so that each class does sort of only a minimal amount of things. So to put this into context, let's create a car. Let's create a boring one. We'll do this one we can run. We'll do public class Toyota Camry. Wonderful car, but very boring to drive. And we'll put in a main method. Public static void main string args. And our curly braces. Okay, and in this car, if we want to, we don't have any methods or anything we use, but if we want to extends car, let me save this. if we extend car, we can utilize these methods without an object. So for example, we can just call on accelerate, because that is now part of this class. We have extended this in the sense that all cars have similar properties, and because we're inheriting this, Toyota Camry can use it. We can also brake. And we can turn. So notice I don't have the object.method syntax on this because there's no object. They're all static methods, just like this one. So when I run it, it executes those methods. So that's what that one means. Now for your own pleasure, look up what the keyword implements is, just like we might implement an action listener. Now we're not limited to these. A Toyota Camry might have its own methods. So we can create our own methods as well. But since we're not creating an object, it's going to be static. And it's not returning anything. So I'm going to call this one Bore Me, because Camrys, although very reliable, are known to be a little boring. Put in whatever message you want. I'll put that in. I'll compile it. And I'll call opponent. Let's check out that it works. It's not working. Oh, there it is. Right there. Forgot my LN. So we can create our own methods unique to the Camry and also utilize the ones from a car. What's also cool is that we could rewrite some of the above ones. This is an advanced concept. We're not going to do this, but say this car braked differently, we could probably rewrite this method. So in this case, we overrode this brake method. So that sort of thing can happen. That's very advanced. I don't think we'll need this in our breakout project that we're going to do. All right, and what's also cool, I'm going to copy all this because I don't drive a Camry. I drive a Ferrari in my dreams. So I am going to save this. And this puts in the inheritance concept to work. Oops, spelled that wrong. So just like if you're playing a first-person shooter or a video game and there's many enemies that maybe you have to shoot, there probably might all extend a base class called enemy that might have certain things, but one might have a different weapon. One might have more health, more accuracy. You might have a higher ranking one that just harder to kill, has more skills, better aim. So that's how that might work, but no sense in coding everything. So I'm going to take this one out. And I might change this to quickly accelerate. I'll compile it. So the way this works, we have Ferrari and we have Camry, and they're both cars. So that means they all have these basic functions that we can inherit rather than having to recode. Now, the Ferrari, it can accelerate slowly when I'm in city traffic, when I'm coming to work, when I'm in the Regis parking lot, unlike a teenager. I operate at that level. But there's probably a sport button I can turn on and quickly accelerate. So I can drive slowly, I can brake, I can turn, I can drive fast, any number of methods. That gives you sort of a quick and dirty overview of how inheritance works. What I would like you now to do is create a base class called pet. If you don't have any pets at home, that's fine. But pets might have certain things in common, like they eat, sleep, they go to the bathroom in the backyard or in a litter box. They, who knows what else they can do. Find some general similarities that most pets do, assuming people don't have a pet tiger or a pet snake. Maybe keep it to cats and dogs or whatever pets you have. And then we're going to create a base class like that with some of the basic methods that our animal might have. But say you have two dogs, they might have two different personalities. Or you might have a cat and a dog, and although they're both pets, and they do some of the same things, sleep, eat, etc., they're also going to have their own characteristics. So create your own version now, and then send me an email when you're done. Sort of demonstrating how inheritance might work with pets. If you don't want to use pets, you can go through the same thing, say with video game bad guys. You might have, like I said, enemies that can shoot, that can hide, that can chase you, that sort of thing. And then there might be several levels. There might be soldiers, sergeants, and then officers. So try to use one of those examples and create your own little inheritance program.